kids, welcome back. It's Apple and Annie again, and in this video we will cover sections 1.1 to 1.4. Let's get started.
Before we start 1.1, we will define some key terms that will appear frequently throughout this section. They are numerical expression, variable expression, and evaluate.
A numerical expression consists of numbers and operations.
Variable is a letter used to represent one or more numbers.
A variable expression consists of numbers, variables, and operations.
And finally, evaluate, as in evaluating a variable expression, means to substitute a number for each variable and evaluate the resulting numerical expression.
Okay, now that we have covered the definitions needed, we will talk you through some example problems.
The first set of problems are evaluate the expression when a is 1, b is 2, and c is 3.5.
The first question asks us what c minus b is. Because the problem tells us that c is 3.5 and b is 2, we can substitute these numbers for the variables c and b. If we do this, we will get 3.5 minus 2. Now, all we have to do is do 3.5 minus 2 to get 1.5. Nice!
The second question asks us to find a over b. Again, because the question tells us that a is 1 and b is 2, all we have to do is substitute these numbers with the corresponding variables to get half or 0.5.
The second set of problems are write a variable expression to represent the phrase.
The first question asks us to find the quotient of a number and 3. Because we know that a quotient is the result of dividing two numbers or variables, we know that the question is asking us to divide a number by 3. Saying x is the unknown number, the answer to this problem is x over 3.
The second question asks us to find the product of 72 and a number. Because we know that a product is the result of multiplying two numbers or variables, we know that the question is asking us to multiply 72 and a number. Again, saying that x is the unknown number, we get 72 times x, or 72x for the answer. Second, 1.2, powers and exponents. Like we did for 1.1, let's cover some definitions before jumping into example problems. They are power, base, and exponents.
Power is the result of a repeated multiplication of the same factor.
Base is the number being multiplied.
An exponent shows the number of times the base is used as a factor.
So here, the base would be 4, the exponent would be 2, the power would be 4 squared, and the factor is 4.
Okay, now let's do some example problems.
The first set of problems asks us to write the power using an exponent.
The first question asks us to find 5.6 times 5.6 times 5.6. Because we're multiplying 5.6 3 times, the exponent is 3, and the base is 5.6 to get the power 5.6 cubed.
The second question is n times n times n times n times n. Because we are multiplying n 5 times, the exponent is 5, and the base is n to get the power n to the 5th power.
The second set of problems asks us to evaluate the power.
The first question is 0.2 squared. Because the exponent is 2 and the base is 0.2, the power expanded is 0.2 times 0.2, which is 0.04.
The second question is 1.4 to the power of 4. When we expand this, we get 1.4 times 1.4 times 1.4 times 1.4, which when multiplied is 3.8416, or 3.8 when rounded to the nearest 10th place.
The third set of problems asks us to evaluate the expression when n equals 1.7.
The first question is n squared. When we expand this, we get n times n. Because the problem tells us that n is 1.7, we know that n times n is the same thing as 1.7 times 1.7, which is 2.89.
The second question is n to the power of 6. When expanded, this is the same thing as n times n times n times n times n times n. Because the question tells us that n is 1.7, this is equal to 1.7 times 1.7 times 1.7 times 1.7 times 1.7 times 1.7, which is 24.137569, or 24.1 when rounded to the nearest 10th place.
Thirdly, we have 1.3 on order of operations.
Before we go to the example problems, here is the order in which you should evaluate expressions.
First, evaluate expressions inside growing symbols. Second, evaluate powers. Third, multiply and divide left to right. And finally, add and subtract left to right.
Use PEMDAS, or parentheses, exponents, multiplication, division, addition, and subtraction to help you memorize this order of operations.
Okay, now, moving on to example problems. The first set of problems asks us to evaluate the expression.
The first question asks us what 17 minus open parenthesis 3 squared minus 2 close parenthesis is. First, because we are following PEMDAS, we need to evaluate the 3 squared inside the parentheses first to get 9. So now we have 9 minus 2 inside the parentheses. Evaluating this, we have 7 inside the parentheses. Now we have 17 minus open parenthesis 7 close parenthesis, which is the same thing as 17 minus 7, which is 10.
The second question is 7 open bracket 2.5 plus 3 open parenthesis 12 minus 7 close parenthesis close bracket. First, because we're following PEMDAS, we need to evaluate 12 minus 7, which is 5. Next, we have to multiply 3 to the 5 we got because we're following PEMDAS. When we do this, we get 7 open bracket 2.5 plus 15 close bracket. Now we add 2.5 and 15 together to get 17.5 because they're brackets. Finally, we multiply 17.5 by 7 to get 122.5.
The second set of problems asks us to evaluate the expression when x equals 3, y equals 4, and z equals 5.
The first question asks us to find x plus 24.4 over y. Because we know that x is 3 and y is 4, we can substitute those values for the corresponding variables. After this, we get 3 plus 24.4 over 4. Doing 24.4 over 4 first, we get 6.1. Next, we can do 3 plus 6.1 to get a final answer of 9.1.
The second question asks us to find y plus z minus 1 squared. Because the question tells us that y equals 4 and z equals 5, we can substitute the values for the corresponding variables to get 4 plus 5 minus 1 squared. First, following PEMDAS, we can do 5 minus 1 to get 4, then square that to get 16. After this, we are left with 4 plus 16, or 20.
And finally, section 1.4 on comparing and ordering integers.
As we did with the other sections, let's define some terms first. We have integers, negative integers, positive integers, absolute value, and opposites.
Integers are 0, a positive whole number, or a negative whole number.
Negative integers are whole numbers less than 0.
Positive integers are whole numbers greater than 0.
Absolute value is a number's distance from 0 on the number line.
And two numbers are opposites if they have the same absolute value but different signs.
Let's get on to the problems. The first set of problems asks us to state the absolute value and opposite of the number.
The first problem asks us to find the values for 17. Because 15 is 15 away from 0, nothing has to be done. And a number that is the same distance away from 0 and has the same opposite sign is negative 15.
The second question asks us to find both values for negative 81. Negative 81 is 81 away from 0, so 81 is the absolute value of negative 81. Next, the number that is the same distance away from 0 but has a different sign is 81.
The second set of problems asks us to evaluate the expression when x is negative 6.
The first question asks us to find the absolute value of 50 minus the absolute value of x. Because 50 is positive, 50 is the absolute value of 50. For x, because it is negative x, the absolute value or the distance from 0 is 6. 50 minus 6 is 44. Nice!
The second question asks us to find negative x minus the absolute value of 7. Because 7 is 7 away from 0, the absolute value of 7 is 7. Now, because x is negative 6, negative 6 would be positive. So the two negatives cancel each other out. We are now left with 6 minus 7, or negative 1.
The third set of problems asks us to write the integers from greatest to least.
The first question asks us to order 35, 60, negative 10, negative 5, and 40. We know that the bigger a positive number gets, the greater it is in value, and the bigger a negative number gets, the smaller it is in value. Using this logic, we can order these numbers to get 60, 40, 35, negative 5, and negative 10.
The second question asks us to order negative 22, negative 30, 7, negative 41, and 0. Using the same logic that we used for the previous question, we can order these numbers to get 7, 0, negative 22, negative 30, and negative 41.
Awesome!
Woohoo! You made it!
That was Exercise 1.1 to 1.4.
We hope you learned a lot from this video and ace your class.
Our next video will be on sections 1.5 to 1.8.
See you soon!
See you soon!